இப்போ டைப் 2 என்னன்னா integral minus infinity infinity p of x by q of x dx, where p of x and q of x are polynomial in x. So when this integral exists, the degree of q of x is at least 2 more than the degree of the p of x. But denominator degree வந்து எப்படி இருக்கணும், கண்டிப்பா 2 more than the numerator இருக்கணும். இப்போ ஃபார் எக்ஸாம்பிள் நியூமரேட்டர்ல வந்து x plus 1 இருந்துச்சுன்னா டினாமினேட்டர்ல வந்து எப்படி இருக்கலாம், x cube plus 5x squared plus 2 இந்த மாதிரி இருக்கலாம், அல்லது x power 4 or x power 5. ஸோ அட்லீஸ்ட் என்ன இருக்கணும், 2 டிகிரி டிஃபரன்ஸ் இருக்கணும் நியூமரேட்டருக்கும் டினாமினேட்டருக்கும். அடுத்தது என்னன்னா இந்த q of x வந்து 0 ஆகக்கூடாது ஃபார் எனி வேல்யூ ஆஃப் x. எந்த எக்ஸுக்கும் டினாமினேட்டர் வந்து என்ன ஆகக்கூடாது, 0ன்னு வரக்கூடாது. இப்போ இந்த ரெண்டு கண்டிஷனை சாட்டிஸ்ஃபை ஆனாதான் என்ன ஆகும், திஸ் எவாலுவேஷன் இஸ் எக்ஸிஸ்ட். சரியா? இப்போ இது எப்படி இன்டிகேட் பண்றோம், the evaluation process is integral over c, so p of z by q of z into dz. Simply என்ன பண்ணிக்கிறேன், x க்கு பதிலா z ன்னு மாத்தி பிரதிக்கிறேன். where c is nothing but a semicircular contour whose diameter has minus r2 plus r, like this. So this is a minus r and this is plus r, and then semicircle. So this is the contour. So here the path is nothing but what, a semicircular contour. If it is of type 2, either minus infinity to plus infinity or 0 to infinity. So என்ன கொடுத்திருந்தாலும் the function வந்து polynomial in x இருந்துச்சுன்னா that comes under type 2, right? If it is type 2, you simply replace x by z and we have to evaluate, which is of the form what, so integral over c f of z dz. You simply apply the formula Cauchy's residue theorem. So 2 pi I into sum of the residues, right? So here c is nothing but what, the semicircular contour. So make it like this. So integral minus r to r f of z dz, and then plus integral over s f of z dz, right? Then after that you put minus r tends to infinity, so you may get so it is a real line, so minus r to r. So when real axis, the value of y is 1, 0, is it right? So suppose z equal to a complex number x plus iy. So on real axis the imaginary part is 0, so simply z equal to x. So if it is a real line, so instead of f of z is, you can write f of x, you make it like this, minus into infinity, so f of x dx. Then applying this Cauchy's lemma. So Cauchy's lemma states that what? So CAUCHY. So Cauchy's lemma states that so f of z is an analytic function, it is also continuous. So integral over s f of z tends to 0 as r tends to infinity. So whenever r tends to infinity, so this integral over s f of z dz tends to 0. Then you may get this value, real integral, right? So that is evaluation process of type 2. Clear? So evaluate integral minus into infinity x squared minus x plus 2 by x power 4 plus 10x squared plus 9 into dx. So it is numerator is a polynomial in x, and denominator is also polynomial in x. So it is of the form what? So integral, so minus into infinity, so p of x by q of x dx. So it comes under type 2. I have to verify that for any value of x it does not vanish. x க்கு என்ன வேல்யூ கொடுத்தாலும் denominator வந்து என்ன ஆகக்கூடாது, 0 ஆகக்கூடாது. புரியுதா? Okay. Then any real value, not a complex one, any real number கொடுத்தா என்ன ஆகக்கூடாது, denominator வந்து 0 ஆகக்கூடாது. இப்போ x க்கு வந்து என்ன நம்பர் கொடுத்தாலும் என்ன ஆகாது, 0 ஆகாது. ஃபர்ஸ்ட் கண்டிஷன். அட்லீஸ்ட் 2 டிகிரி வந்து டிஃபரன்ஸ் இருக்கும், நியூமரேட்டருக்கு டினாமினேட்டருக்கு என்ன இருக்கும், 2 degree difference இருக்கணும். It satisfies, therefore the integral exists. So now what will be the procedure now? We simply replace x by z. So let I equal integral over c z squared minus z plus 2 by z power 4 plus 10 z squared plus 9 into dz, where c is the semicircular contour whose diameter is minus r to r, and the semicircle above the real axis is s. Okay, this is a contour here. Now it is of the form what? So integral over c f of z dz. இந்த ஃபார்முலா இருக்கு. இது வந்து f of z நீ வச்சுக்கலாம். இப்போ f of z dz னா காசியஸ் ரெசிடியூ தியரம் பிரகாரம் என்ன வரும்? 2 pi I into sum of the residues. இதுதான் நமக்கு ஃபார்முலா. நமக்கு ரெசிடியூ கண்டுபிடிக்கணும் அப்படின்னா we need poles, right? The poles are given by so put denominator equal to 0. So z power 4 plus 10z squared plus 9 equal to 0. And our factor panina z squared plus 1 into z squared plus 9 equal to 0. Yeah. So then our z squared plus 1 equal to 0, which implies z equal to plus or minus I, and z squared equal z squared plus 9 equal to 0, equal to z equal to plus or minus 3i. So what are the poles now? So z equal to I and minus I, 3i and minus 3i. So which is lies inside? So 1 is lies inside and 3i is lies inside. If it is negative, you can write this. So z equal to I என்ன? இது வந்து காம்ப்ளெக்ஸ் நம்பர் எழுதலாம். என்னது 0,1. இது வந்து என்னது 0,-1. இது வந்து என்னது 0,3. 0,-3. இப்போ இது எந்த பாயிண்ட் எல்லாம் லைஸ் இன்சைடா இருக்க முடியும்? ஸோ பிளஸ்ல வர பாயிண்ட்ஸ் மட்டும் என்னவா இருக்கும்? லைஸ் இன்சைடா இருக்கும். y வந்து நெகட்டிவா வரதெல்லாம் என்ன இருக்கும்? லைஸ் அவுட் சைட். ஸோ அப்பர் பார்ட்னால என்னது y வந்து பாசிட்டிவா இருக்கும். y நெகட்டிவ்ல வரது எல்லாமே அவுட் சைட்ல வந்துடும். சரியா? அப்போ y பாயிண்ட் இமேஜினரி பார்ட் நெகட்டிவ்ல வந்துச்சுன்னா ஆப்வியஸ்லி தட் பாயிண்ட் இஸ் லைஸ் outside. Therefore z equal to 1 and z equal to 3i are lies inside. Clear? So we need a residue at z equal to I and z equal to 3i. So residue at z equal to I and 3i are inside, and simple poles. Yeah. Power வந்து என்ன இருக்கு? 1 தான் இருக்கு ரெண்டுக்கும். Right? And z equal to minus I minus 3i are outside. So therefore residue at z equal to I. So simple போலுங்கனால என்ன ஃபார்முலா நமக்கு? இப்போ இது வந்து p of z by q of z ங்கிற ஃபார்முலா இருக்கு. So p of z by z square minus z plus 2 by the derivative of the denominator. So 4z cube then plus 20z. So z equal to I. இந்த ஃபார்முலா அப்ளை பண்ணலாம். அல்லது இன்னொரு ஃபார்முலா என்ன கொடுத்துருக்கேன்? r equal limit z tends to I z minus I into f of z. என்னது z square minus z plus 2 by this is nothing but z squared plus 1 into z squared plus 9. So I can write this as z plus I into z minus I. Yeah, in the function இப்படி எழுதிக்கலாம். இப்போ இந்த either you can apply this method or this method, right? z equal to I கொடுத்தீங்கன்னா என்ன வரும்? So I squared minus I plus 2 by I plus I is 2i. So I squared is minus 1 plus 9. Whenever this minus 1. So 1 minus I by 2i into 8. So 1 minus I by 16i. Is it right? Check panika. I squared only minus 1. Minus 1 plus 2 plus 1. So 1 minus I by 16i. Right? The residue at next point. Residue at z equal to 3i. So residue at z equal to 3i. இது என்னதான் simple pole தான். So limit z tends to 3i, z minus 3i into z square minus z plus 2 by z square plus 1 into z plus 3i into z minus 3i. This will get cancelled now. When around 3i substitute point minus 9 minus 3i plus 2 by 3i substitute பண்ணனா வரும் minus 9 plus 1 into 3i plus 3i 6i. So minus 7 minus 3i by minus 8 into 6i. Clear? Okay. We substitute in 1. No. So equation 1 becomes 2 pi I equal 2 pi I into sum of the residues 1 minus I by 16i, then plus minus 7 minus 3i by 48, yeah. So minus 48. So minus minus plus ஆயிடுமா, எல்லாத்தையும் plus போட்டுக்க. So 48i. So LCM என்ன வரும் 48i. So 2 pi I into so 48i. So 3 so 3 minus 3i plus 7 plus 3i. 3i get cancelled. So this I get cancelled. When our 2 kadchina 24 whenever the 3 plus 7 10. So 10 pi by 24. The simplify na varum 5 pi by 12, right? So I, what is I? I inga integral over C f of z dz. Yeah. So integral over C f of z vandana z squared. What is f of z? Z squared minus z plus 2 by z power 4 plus 10z plus 9 into dz. Is this equal 5 pi by 12. Someone can know x11, yeah. But this C is nothing but what? C is nothing but a semicircular contour. So minus R to R and then S. So this is C. So now we replace C by this. So minus R to R. So in this real line, the value of Z is X, right? So minus R to R na x squared minus x plus 2 by x power 4 plus 10x plus 9 into dx equal to 5 pi by 12, sorry, plus minus R to R, then S, so integral over S, f of z dz. So f of z is z square minus z plus 2 by z power 4 plus 10z plus 9 into dz equal to 5 pi by 12. And now put R tends to infinity and apply Cauchy's lemma. So you may get integral minus infinity to infinity x squared minus x plus 2 by x power 4 plus 10x plus 9 into dx. This become, this tends to 0 by applying Cauchy's lemma. So plus 0 equal to 5 pi by 12. So therefore we may get minus into infinity x square minus x plus 2 by x power 4 plus 10x plus 9 into dx equal to 5 pi by 12. These are required answer. Next problem, so evaluate integral 0 to infinity x square dx by x square plus 1 into x square plus 4. But 0 to infinity வந்தாலும் நமக்கு வந்து இதை மட்டும் செக் பண்ணினா போதும். The polynomial in x இருந்துச்சுன்னா that is a type 2. So it is of type 2. So therefore we make it what? So let I equal integral over c z square dz by z squared plus 1 into z squared plus 4. Yeah. Where C is what? Semicircle. So that is minus R2 plus R and then this. So this is a contour, right? So therefore apply the Cauchy's residue theorem, so make it what? So 2 pi I into sum of the residues. So take it as 1. So poles are given by now z squared plus 1 into z squared plus 4 equal to 0. So z squared plus 1 equal to 0. So z equal to plus or minus I. Then z squared plus 4 equal to 0. So z equal to plus or minus 2I. So z equal to I and 2I are inside and z equal to minus I and minus 2I are outside. So therefore you may find out the residue at these singularities. Z equal to I and z equal to 2I. So z equal to I. So residue at z equal to I. So it is a simple pole. So R1 equal to limit z tends to I. So z minus I into f of z is z squared by, so this can be written as what? Z plus I into z minus I into z squared plus 4. Substitute I, so minus 1 by 2I minus 1 plus 4 3, so minus 1 by 6I. So residue at z equal to 2I. Now R2 equal to, so limit z tends to 2I, z minus 2I into z squared by z squared plus 1 into z plus 2I into z minus 2I. Substitute 2I, so minus 4 by minus 4 plus 1 minus 3 into 4I. So you may get 1 by 3I. Yeah. Therefore, equation 1 becomes, now the integral over C z squared dz by z squared plus 1 into z squared plus 4 equal to 2 pi I into sum of the residues minus 1 by 6I plus 1 by 3I. Now 2 pi I into, we take LCM 6I minus 1 plus 2, 1 over the plus 1. So this I get cancelled, this 3 now, so pi by 3, yeah, minus 1 plus 2, 1. So now you can replace C as C1 replace panna, integral minus R to R. So in this integral z is x, so x squared dx by x squared plus 1 into x squared plus 4 plus integral over s z squared dz by z squared plus 1 into z squared plus 4 equal to 5 by 3. After that, so putting r tends to infinity and apply Cauchy's lemma. So you may get integral minus infinity to infinity x squared dx by x squared plus 1 into x squared plus 4 and this become 0, tends to 0, right? Equal to I by 3. So நமக்கு என்ன வேணும்? 0 to infinity வேணும் இல்லையா? So here limit minus into infinity. So this is an even function, is it right? You replace x by minus x. So there is no change in this function. Therefore it is an even function. So if it is even function, so we can write as what? 2 times integral 0 to infinity x squared dx by x squared plus 1 into x squared plus 4 equal to 5 by 3. So therefore integral 0 to infinity x squared dx by x squared plus 1 into x squared plus 4 equal to 5 by 6. Right? You will try these problems. So evaluate the following integrals. Integral minus into infinity x squared dx by x squared plus a squared into x squared plus b squared where a greater than b greater than c. Now particular case பார்த்திருக்கோம். So இங்க வந்து general case கொடுத்திருக்காங்க. So இதோட answer வந்து 5 by a plus b. So இந்த problem வந்து integral minus into infinity x squared dx by x squared plus 1 the whole square x squared plus 2x plus 2. So இந்த problemக்கு என்ன answerனா 7 pi by 50. The third problem integral 0 to infinity. Lastly என்ன பண்ணணுமே இது is a even function. So இந்த மாதிரி தான் உனக்கு கிடைக்கும். இப்போ நம்ம 2 times ன்னு போட்டு இதை எழுதிக்கணும். Right? So 0 to infinity dx by x squared plus a squared the whole cube. So 3 pi by 16 a power 5. You can verify these answers. Right? Type பார்த்தீங்கன்னா integral minus into infinity. So p of x into sin mx by q of x or integral minus into infinity p of x into cos mx by q of x into dx. இப்போ sin போன டைப்புக்கு இதுக்கு என்ன டிஃபரன்ஸ் அப்படின்னா ஸோ போன டைப்பில் p of x by q of x மட்டும் இருந்துச்சு. இந்த sin mxும் cos mxும் கிடையாது இல்லையா? இப்போ அந்த டைம் அந்த எய்தர் sin ஆர் cos வந்துச்சு அப்படின்னா this is a third type. ஃபர்ஸ்ட் டைப்ல என்னது sin theta and cos theta லிமிட் வந்து எப்படி இருந்துச்சு 0 to 2 pi அப்படி இருந்தால் அது ஃபர்ஸ்ட் டைப். இங்கே வந்து லிமிட் எப்படி இருக்கும் minus into infinity or 0 to infinity. ஸோ எப்படி இருந்தாலும் இது என்ன தான் டைப் 2 தான் சாரி டைப் 3. So what are the conditions? The degree of q of x is greater than the degree of p of x and the value of m is greater than 0 and the q of x is does not vanish any real value of x. See these are the three conditions. Whenever these three conditions are satisfied, so this limit, this integral exists. Right? What will be the evaluation procedure? You replace x by z, right? So integral over c p of z by q of z into the sin mx or cos mx. You may replace this what e power i mz into dz. So sin வந்தாலும் cos வந்தாலும் என்ன பண்ணிக்கிறேன் e power i mz ன்னு எழுதிக்கிறேன். Right? But c is the same contour as type 2. Seeing c is a semicircle. So like so minus r to plus r. This yes. Now you can say this is an f of z. So now I apply Cauchy's residue theorem. Cauchy's residue theorem is 2 pi I into sum of the residues. And then the c is like this one. So integral minus r to r. Then f of z dz plus integral over s. I can write this as f of z in this case. அல்லது இதோடு இப்படி எழுதிக்கலாம் e power i mz p of z by q of z c power i mz f of z dz where f of z is p of z by q of z, right? This is equal to this 2 pi I into sum of the residues, right? And after that putting r tends to infinity and apply Jordan's lemma and apply Jordan's lemma. So Jordan's lemma says that f of z is continuous and f of z integral over s f of z is dz tends to 0 as r tends to infinity, and then this term is tends to infinity. This integral tends to infinity by Jordan's lemma. So you may get the required integral. Clear? So this is evaluation process. And next type problem para. So evaluate integral 0 to infinity x sin x by x square plus a square dx by contour integration. So it is of type 3. X vandirukku, sin term vandirukku, then limit வந்து 0 to infinity இருக்கு. So இந்த டைப்ல வந்தாலே என்னது? So type 3. இப்போ என்ன எழுதணும்? சொல்யூஷன் எப்படி சொல்லியிருக்கேன்? What will be the procedure? Let I equals integral over c is it the sin எப்படி எழுதியிருக்கேன்? e power iz இல்லையா by z square plus a square into dz, where c is the semicircular contour minus r to r and then this s. S is a semicircle whose radius is less than or equal to r. Now, so this is of the form what? You can take it as this is f of z. So you can apply the residue theorem. So 2 pi I into sum of the residues. This is 1. The poles are given by put denominator equal to 0. So z squared plus a squared equal to 0. So z equal to plus or minus ai. So z equal to ai and z equal to minus ai. So here plus ai lies inside and minus ai lies outside. So this is inside and this is outside. Therefore your residue at z equal to ai கண்டுபிடிக்கணும். So residue at z equal to ai. So it is a simple pole. So it is of the form p of z by q of z. You can apply any one of the formula. So r1 equal to z e power I z by differentiate it 2z. Z equal to ei. So this z get cancelled. So e power minus a by 2. Right? So therefore what? So integral over c z e power I z by z squared plus a squared into dz equal to 2 pi I into sum of the residues. So only one residue, so e power minus a by 2. So this 2 to get cancelled. Right? Now you will place c now. What is c? So now this c is replaced by integral minus r to r. So in this limit the value of z is x. So x into e power ix by x squared plus a squared into dx plus integral over s e power iz by z squared plus a squared dz equal I into pi into e power minus a. Clear? Okay. Now, so putting r tends to infinity, so and apply Jordan's lemma. So we get integral minus into infinity x into e power ix by x squared plus a squared into dx. So by Jordan's lemma this time becomes 0 equal to I into pi into e power minus a. So now integral minus into infinity x by x squared plus a squared. This e power ax is nothing but what? Cos x plus I sin x into dx equal to, I can write this as 0 plus I into pi into e power minus a. So here equating imaginary part, So I'll get why are equating imaginary part? Now question நம்ம என்ன கண்டுபிடிக்கணும்? Integral 0 to infinity x into sin x by x square plus a square dx. So if it is cos x, equating real part. சரியா? questionல வந்து sin x இருந்துச்சு அப்படின்னா equating imaginary part பண்ணணும். cos x இருந்துச்சு அப்படின்னா equating real part பண்ணணும். இப்போ equating imaginary part will get left hand side. Integral minus into infinity x into sin x by x square plus a square into dx equal to pi into e power minus e. So it is an even function, right? So numerator, this is an odd, this is odd into odd, even. So even by even, even. So it is an even function. So we can write this as 2 times 0 to infinity x sin x by x square plus a square dx equal to so pi into e power minus a. So therefore, integral 0 to infinity x sin x by x square plus a square dx equal to pi by 2 into e power minus a. Right? Try this problem. So evaluate the following: integral minus into infinity cos x dx by x square plus a square into x square plus b square. You can verify this answer. Pi by a square minus b squared e power minus b by b minus e power minus a by a. The second problem, integral 0 to infinity cos ax by x square plus b square the whole square into dx. You can verify this pi by 4 b cube into 1 plus ab e power minus ab. Right?